Okay, so chapter 1, we are looking at 2D and 3D flow, and what is the main thing that we're focusing on is equation of streamline. Okay, so just to recap, we have a few equation which is important. The first is a vector equation. So you should know in what kind of form is 3D, what kind of form is 2D, what kind of form is 1D. And then the definition of streamline, the equation for streamline, with this one, dy over dx v divided by u. And then we have introduced you an online tools, the plotter, graph plotter online, so that you can use this in your test or final exam to sketch the shape of the streamline. Okay, and then the definition of straight line. Straight line means the photo, the gray basketball that passed through. So okay, path line is the red dot line that show the movement of the element. Okay, right. So let's go to tutorial question. So if you referring to your chapter 1 tutorial question, the last question in your tutorial question, it will be question number 16, which is in the last page of the tutorial 1. Yeah. All right. So yeah, again, this for chapter 1 actually is application of mathematics, of differentiation, of integration. Okay, of integration. So we will keep repeating the same method throughout the day. So let's look at the question, and then what is the question required us to do. So we are given a water flow that is oscillating slits that show in the diagram below or on your screen on the left hand side. So you can see that the sprinkler is projecting some air. The Q is the flow from below, and then is discharged from these surfaces. And you are given a reference axis, which is at the center of this head, denoted by O origin, and your X direction is to the right, and your Y direction is vertical direction. So if you are dealing with 3D, means Z is coming up from your screen. Yeah. So let's look at the equation given. So the equation given, the velocity field. Now, last two lecture, we already introduced you what is velocity vector, velocity field, and we already used the online plotter to plot the velocity field. So we are given the velocity field, the vector equation, which is given by v equal u naught sine omega t minus y minus v naught, and then I hat plus v naught j hat. So you're given where u naught, v naught, and w, the omega, is a constant. So don't panic when you look at this kind of equation. As long as you memorize or you recall what is the vector equation, whether you look at the form, then you can tell whether this is a 2D problem, a 3D problem, or maybe it's a 1D problem. So this equation is v equal to ui plus vj plus wk. There's no w there. There's no k vector form there. So you're only having I and j. So it's a 2D problem, which is much simpler to solve. And then to further simplify your calculation, the question already mentioned u naught, v naught, and omega or w in the equation is a constant. So this is a constant value. You can assume this one as 1. W also constant value, you can assume as 1. And then what else? V naught also you can assume as 1. Assume as a constant value, a value that you can factor out. Okay. Then it further introduced the scenario. So if you continue to read the question, so the y component of the velocity remain constant. So it gives you a condition where whichever the flow flowing in the y direction remain constant, which is your v equal to v naught. It means that you know that if you talk about vector, all the movement to x-axis you denote as u. All the movement along y-axis you denote as v. And then z is w. So in this case, it tells you that the velocity remain constant in y-axis. So the the v component is a constant value. It's a constant value. And then the x component of velocity at y equals 0, which is at here. If if there is any movement along x-axis, the question say at y equals 0, which is at the origin here, co-incline with the velocity of the oscillating sprinkle. So your sprinkle is actually oscillating. The head is given by this equation. So the head oscillating frequency given by u equal to u naught sine omega t at y equal to 0. So at here, the sprinkle oscillate in the x direction, meaning you can imagine that actually you are spraying water when you wash your car or wash your motorbike. You are using a hose, right? So the hose actually, you are holding the hose and then you move sideways to clean your car or motorbikes. So there is a two equation here. One is the velocity field, which is the red arrow equation. And then there is a sprinkle head movement. There are two equations there, which is move in the u direction, given by this equation, u naught sine wt, which is, if you recall back your trigonometry equation, this actually is a sinusoidal equation or sine wave equation, because u naught is a constant, you can assume as 1. Dub omega, you know that is a rotational speed times t is a constant value or is an angle. So sine angle is a sine wave pattern. Okay, so just a remind, this module is actually a combination of what you learned from year 1 until your year 3 module, including all the mathematics model. You have to call them back. You have to call them back. So as long as you understand what is given in the question, you are given a velocity field. Then think back, what is the form of vector that you have? You're having what kind of case? You're having a 3D case, 2D case, or 1D case. In this case, you're having a 2D case. All right, then you're having another equation which is given by the sprinkle head velocity, movement velocity, movement motion equation, u equal to sine wave equation. So we need to find something. There are 3 sections there. So I'm going to go very slow for these 3 sections. So we're going to look at the first one first. So the first one asks us to determine the streamline. Okay, determine the streamline at a certain time. Okay, you need to find 2 scenarios. One is t equals 0. Another scenario is t equal to pi over 2 omega. Okay, your time unit is not in second, but is in the, you can say in second, but is throughout pi over 2 omega unit. Okay. And then the second thing you need to find from this answer will be, you need to define the path line. There's a way to calculate path line, and we're going to introduce you through this example. Previously, we looked at streamline, but today we're going to show you how to find the path line. Actually, it's quite easy. And from the origin, at the two scenarios. So one at the t equal to 0 and t equal to pi divided by 2. I think this one I'm missing. There's a 2 omega here, right? Pi 2 omega. All right. So then the last one is that you discuss the shape of the straight line that passed through the origin. Now section C, when we come to section C, maybe I need you to look at the question again and again, try to understand the mathematical equation. Okay, because section C will actually is interpretation of polynomial equation. So section C actually is just a mathematic how deep or how good you understanding on the equation. All right. So let's start with section 1 or A. A. So A, we need to determine the streamline that pass through the origin here at 2 scenarios. We will go for t equal to 0 first, and then we solve for t equal to this one. So as long as, and you have to know that you are having two set of equation here. One is the velocity field, one is the sprinkle head here. You have to know, you have to aware about this one. And then both equation is having the t term. For velocity field, you have a t term inside the equation, sine wt minus y v naught. For the I, you have the t here. So you have to be careful when you consider the first scenario with t equal to 0, where later you substitute this 0 into the velocity field. And also you substitute 0, t equal to 0 for the sprinkle head movement, which is sine wt, the t here. After you solve for the first scenario, you will compare to the second scenario where you substitute t again into the velocity field t term here. Okay, then you solve for the head movement. Also substitute the t inside here. All right. So let's get ready to solve your section A question. We focus on streamline. Okay. Maybe this one is a bit too fast. Okay, so the first one, the first equation or first part is that we focus on, hold on. Let's focus on streamline by two scenario, t equals 0, t equal to pi over 2 omega. Again, recall that the v equal to v naught sine wt minus y divided by v naught I hat plus v naught j hat. If you write this one in your test or final exam, you get 1 mark. Again, don't leave your answer sheet empty. You extract the information, we will give you the marks for your understanding. Okay, before we move forward, let me ask someone. Okay, the first question go to Dinesh. Are you there, Dinesh?
Yes, sir.
Okay, you look at the screen here. You look at the velocity field. This question will be the same like what I asked you previously. So if you look at this question, this equation show you 3D dimension, 2D dimension, or 1D dimension?
2D.
2D. Why?
Because got I and V only.
I and?
V only. I and J only.
Okay, correct. All right, excellent. So from there, you can extract the equation, put in the general form, and then you can extract what is your U, what is your V, like what you see on the screen on the left-hand side in red color. Yeah. So I already extract them. Okay, yeah. Dinesh, thank you so much. The question already answered by you. Yeah. So we continue solving the question. So U equal this component. Okay, hold on. Okay, this component is U, this component is V. So you extract them out. You write U equal to U naught sine something, you just copy 100%. And then V equal to V naught. These two will give you, it depends. It depends. So sometimes I'll give you 1 mark, sometimes I give you 2 marks. For this one 1 mark, this one 1 mark. So this is how I give you marks. You write the general equation or extract information from the question, you'll get some marks. Then you start telling me whether you understand from this vector equation or not. So you tell me what is U, what is V, I'll give you some marks there. All right, the next one. just to test you on just to evaluate whether you understand what is streamline. So streamline equation given by this one. Okay, let me clear the marking. So streamline equation that we already agree that we can, that we can write as dy over dx equal to divided by u. Okay, so if you don't understand this one, go back to the previous lecture slides and have a look. Yeah. So at this moment, we assume you already understand. Streamline equation always tied up with this equation. Dy over dx equal v divided by u. So again, in test, if you write this one, you'll get 1 mark for this equation. Right. So all the steps you written in your answer, you'll carry some marks there. All right. So it's quite easy to score. Huh? All right. So once you write the equation, the next step is just substitution. Substitution of your u and v inside this equation. All right. Now don't let the complex equation to scare you away. Important you understand the fundamental steps. All right. So just to recap, what is the important step here? The first one, write the equation. Okay, write the equation. Write this equation. And then write the streamline equation. These are the two major components. All right, write the equation, then convert them to find what is u, v, and w. In this case, there is a value for w. The w value, if the question asks you in 3-dimensional, w in this case is 0. Yeah? Although there is no w there, means that mathematically you can tell the reader or you can tell the audience that you understand that when you write a vector, there is a value for 3-dimensional. If the question try to lead you to solve a 3-dimensional problems, okay, the value for w in this case is 0. There's a value there. The value is 0. Okay. After that, you substitute. The rest is mathematics. So don't get scared by the complex sign equation there. After you get after that, after you get the dy dx equal v divided by u, you substitute, then you integrate, you will get streamline. Okay, recall integration equation, recall recall differentiation equation, recall integration skill, you get streamline. Okay, standard step, write the equation, call what is u and v, recall dy dx equal to v divided by u. After that, integrate this formula, right? Put your y to one side, put your x to one side, then integrate. You'll get the answer. So I'm showing you on the screen here is the substitution of your v and u. So v equal to v naught, u equal to this one. Yeah? Again, stop me if I go too fast. Just stop me, or anything that doesn't make sense to you. Just stop me and ask me question. Right? So the next step, the next line you see on the screen here, this actually I'm moving everything that deal with the y to the left hand side, and everything that deal with the x to the right hand side. So I move my dx from the left to right, my y component to the left hand side. Okay, because I want to clear the differentiation equation or fraction number into a linear equation. So just a rearrangement of equation, you will get your u naught sine something dy equal to v naught dx. All right. Right. So far clear for all of you, able to follow. Cool, you able to follow? Cool.
Yeah, but I need to refer back the last week one.
Yeah, the previous one. Yeah. Yeah, but previously the concept you understand, right?
Yeah.
Okay, good. Yeah. So let's continue. Okay, up to this stage, we already arrived at one linear equation. Then we start integrate already. So what I mean by integrate? You put in the integrate sign on the left hand side. and also the right hand side. So you integrate the left hand side, you integrate dy, means you focus on the y term. This how to integrate this one, you need to flip your advanced mathematics or your calculus textbook. Yeah, how when you integrate sine something, what you get. Okay, you need to go and look back on your calculus skill or integration skill. So when you integrate, you arrive at this answer. So u naught v naught omega cos, and sine will become cos, and then the integration bracket value. And on the right hand side, if you integrate a constant value, you will get additional x plus a constant value. Last lecture I already explained, when you don't have the integration boundary value along your integration sign, you will get a constant value in your answer. Okay, so if you don't understand why suddenly there's a constant value, again, go back to your calculus or advanced mathematics integration chapter. Okay. All right, now we're still at the integration step. Then we need to solve. Every time when you don't have the boundary layer or boundary condition in your integration steps, remember to solve for your constant value. So how do you solve for constant value? You just substitute the known coordinate, especially at the origin. The question already helped you to give you hints already at origin. Once you substitute the origin coordinate, Cartesian coordinate, you're able to solve C, which is in this equation. The origin coordinate will be 0 for your x and y. X0, Y0. This means you substitute x0, y0 in this equation. You're able to solve. Okay. Now find C. You have two information that you can extract from the question. So one is the origin, the word origin itself. Another tips is that you have the two time frame here. So again, I remind you just now that we need to look at two scenarios. So you have the origin, which is the x and y equal to 0, and the time equal to 0. We need to consider these two scenarios. So each scenario will give you different C constant value. So we start with the first set, which is we use xy equals 0. Streamline, we set at t equals to 0 first. Later, we will look at t equal to pi over 2 omega. Okay, in this case, because in the second equation that you see on the screen here, we need to solve the constant value. We substitute x here, substitute y inside here. We substitute t equals 0 here. Try to tell me what is C after you substitute all the value. Okay, I'm going to give you one, maybe 30 seconds to find it out. I'm going to ask Raj. Raj, stand by the answer for C. And maybe Shirley, you can start calculating what is t equal to pi over 2 omega in another case. Just to tell me what is the, Shirley, you ready for the constant value for the C at the second scenario where we look at the origin, but the time is pi over 2 omega. What is the C? Okay. The rest, you can also do some simple calculation at your desk while waiting for Raj to answer. Raj, you ready to answer?
Wait, sir.
What is the C? If you x 0, y 0, t 0, what do you get?
Sir.
Mm.
The second one, right? The pi over 2 omega, right? They want the x-axis and the y-axis also same, right? It's
Yeah,
0,
correct.
right?
Yeah, because it's at the origin.
Okay.
The first part A, it asks you about at origin. So the x and y is 0. Of course, when it comes to test and exam, it will be a bit tricky. I will ask you somebody else, somewhere else, but I give you the coordinate. So you can substitute the x and y coordinate. In this case,
Okay.
because we are looking at tutorial, so we go for the easy, soft question first.
Okay, sir.
All right. Okay, Raj, you should able to answer your answer now. Yeah, what's your C?
So the UO bracket VO over omega.
Okay, that is your answer, right?
Yes, sir.
Okay, correct. So your C is V naught, right? V naught or V0, V0 over omega. So what about, okay, so after that, you substitute, remember, after you find a constant, don't leave it there, right? Just substitute back to the general equation that you find in the middle of the screen here, which is the second equation. After you find C, you substitute back, you will get the complete equation. Okay, you get a complete equation where give you the one that you see on the screen here, right? So what is the equation of streamline for the first case at origin t equal to 0? You just rearrange this one and write it back, or you give me the equation of this one. Also, I give you full mark. But what I was expecting from you will be always give your answer, let's say y equal to something or x equal to something on the left hand side. Okay, f equal to u not w cos omega y over v naught minus 1. So wisely I have a 1 here because I factor out my my u naught over omega to outside. So I will be seeing cos something minus 1 in my equation. Okay, later I will show you how to plot this one in the graph plotter later on. Okay, so we have done for the origin at t equal to 0. Now I will give chance Shirley to answer. What happened to the C when your t equal to pi over 2 omega? What is your C, Shirley? Have you done the calculation?
Yes, sir. But sir, I have a question.
Yes.
At
Okay.
here, right? I will need to change to degree or radian for the best.
For the cos something here,
For
is
the
it?
best.
For the
Yes.
yeah. So
Cause something.
yeah, for this case, we will just calculate calculate in degree, cos degree here. But when you deal with omega, the is in term of radian. Okay.
Oh, so I still remain it in degree.
Yes, correct. So yeah.
So I got 0.9996 UO bracket VO over omega.
Okay. So let's check whether Shirley get the correct answer. So if you look at the screen here, we are now looking at the second case where t equal to pi over 2 omega, and we need to find the c. So again, substitute your x equal to xy equal to 0, and you substitute pi over 2 omega inside there. Okay. Now, usually for this kind of question, your c is 0. Yeah. Actually, the answer is 0. Why? Why is it?
So I got two answers because if I change to radian, right, the
Yeah.
C will become 0.
Yes. Okay. So in this case, if you simplify it without pressing the digital number, all right. So you substitute the t equal to 2 omega here. You can cancel out all the term inside here. All right. Yeah. So like Shirley asked just now, cos if you substitute your t as 2 over 2 omega, you will get pi over 2, pi over 2. So pi over 2, cos pi over 2. Let me press my scientific calculator whether I can get the answer. Let me check on my side. Pi over 2. Okay, you will get 0.999. Okay, 0.999. But we can simplify as 1. Okay, or cos 90. Right? Pi over 2 is cos 90 degree. Okay, sorry. Cos 90 is 0. Okay, pi over 2 is 90 degree. All right. Yeah, just to clarify, the thing that you might face when you deal with omega. So in this case, if you substitute there, you will get cos pi over 2. This term is in radian. Apologize for my mouse movement. It's not as sensitive that I need it to be. So this is radian. Oops. This is radian. So you know that your cos is some in degree. Cos degree. All right. So you need to change this radian to degree. So pi over 2, you know that 360 equal to 2 pi. So half of the, sorry, do I mention the correct thing? Okay, 2 pi go to 360. So half is 180. No, half. Yeah, half is 90, correct. Pi over 2 is 90. So cos 90 equal to 0. Okay, you have to understand the pi term, you need to change it to degree. Yeah, so this is the area when student cannot score full marks because they forget to change the pi term into degree. Okay, you need to know how to change the radian pi into degree. So pi over 2 is 90 degree. So cos 90 equal to 0. Okay, so cos 90, 0. So you get 0, cos 0 equal to 0. Cos 90 equal to 0. 0. Because this is 0. This is 0 because your y is 0. All right. So cos 0 is 0. Your x is 0. So on the left hand side is totally 0, although the front one is constant value. Constant value times 0, you get 0. So C is 0. Okay, yeah. So good job, Marshally, for raising this kind of confused scenario where you arrive at whether you need to change or not. So in this case, the answer is you need to change to degree to get the C. Right, Shirley, you clear?
Yes, sir, I'm clear.
Okay, good. Cool, cool. You need to take care. This is also one of your careless mistakes. Now, because Cool is my previous student in other modules, so I know some of his weakness. So, yeah. Okay, let's continue. Once you get the C, you substitute back to the question equation. So in this case, your C is no longer there, and you rewrite in terms of streamline equation, which is x equal to u not w cos omega something minus v over v naught. So you have two equations for section A. Okay, you have two equations. All right, and both answer give you correct. If you look at the screen here, you have two answer. One is in term of cos. On the left hand side here is the one that you derive from the question. So sometimes the question will ask you to compare side by side what is the what is different between t equal to 0 and t equal to pi over 2 omega. So because the previous one, let me see, the previous one is in cos minus something. Of course, the shape of the graph is still same. So sometimes if you need to make comparison, sometimes you need to answer in the sign. So remember that when you take something pi over 2 minus something, when you convert into sign, you can straight away write in this form, sine over something. Okay, now both answer give you the full mark for this section, for this t equal pi over 2 omega. Okay, so this is the first section 1. All right, now then I will show you the diagram on the screen here, which is you can stretch from the calculator, the plot calculator. So you have two equations there, two equations. One is the x equal to u naught over omega cos something minus 1. And also another scenario with t equal to pi over 2 omega, you have x equal to u naught over omega sine wy over square. And you can see the shape of the graph here. So just to illustrate you how to use the plotter, before you go to the plotter, I want you to focus on the value inside the equation. So for t equal to 0, you have x equal to u naught over omega. So just to remind yourself that this is a constant value. So constant value you can put in any full number in the mathematics. It can be 1, of course it cannot be 0. A minimum number you can go is, it can be negative, it can be positive, right? It can be positive value or negative value, as long as it's a full number. And then cos something. So if you take the constant value omega and v naught omega divided by y, you will get a constant value here. So it can be positive, it can be negative. But anyway, remember to change this one into degree. This value here, because when you see omega, you always in the term of radian or pi, then you need to change into degree so that you can get the normal trigonometry value, -1. And this one also, the second case also, you have the u naught over omega is a constant value. Again, it can be positive or negative, but it's a full number. Then sine over something. This is also, you need to change to full number. Okay, so how do you plot this kind of graph in the plotter? So I'm going to demonstrate to you, or you can follow along if you want. So you just go to Google and type graph plotter. Okay, graph plotter. You can choose any link that you're familiar, but usually I will choose the first one or the second one. So I go to Desmond calculator, and maybe I put side by side, or I put yeah, something like that, so that you can see it. So the first equation is x equal to constant value cos something, right? Cos something minus 1. So when t equal to 0, the equation is x. You can just type in using your keyword, x equal to, and we know that this is a constant value. So constant value, I can put it as 1, and then I bracket cos, and then maybe I'll put a constant value also, maybe cos 1, cos something, cos, I put just a constant value, just a constant value, just a value of a, -1, and then I close the bracket. Okay, so I get the shape of the t equal to 0 waveform like this. Okay. Now another one is that if I want to further detail the equation, for example, you know that this is a constant value, and we can do the same in this case, because the first example here I use a to represent a constant value in this bracket here. So I can do the same principle by giving the second equation. I will just write it as b, or I just change a little bit, maybe b cos c minus 1. Okay, now it will ask you to, there is a function come out below the screen here, add slider b and c. I will just press all. meaning I can control the value of my B and C on the graph. So meaning, you know that U over W is something that you can calculate when the question asks you, give you some numbers. U naught, it can be given some number. Omega is also some number. So you can calculate a certain number. Let's say the number of U naught over omega is 1, then you stop at 1. You can straight away use the first equation. If not, then maybe the question will be tricky a little bit. You ask you what will happen if this number is increased. So you just slide this number to the left and right. You will see what happened to the graph. Okay, you'll see what happened to the graph. Okay, the graph will move left, right. Of course, if you don't want to, you will want to make the constant value C here as what we see there. We don't want to have a mover. We just cancel it. So you get the graph here. So we just play around with the graph. So as you can see, if the constant value is positive, increasing the magnitude of U naught over omega, you can see as I increase the value from 1, maybe I'll use my keyboard to increase the number. Oh, cannot. So I drag from 1, I increase to 2, increase to 3, increase to 4, increase to 5. Then you'll see as you increase the magnitude, the movement of the streamline will be different. Okay, now this one is a little bit very near to vibration module. So basically this calculator will help you to understand what's happening. So what happens if the magnitude is negative? You go to another axis. Okay. All right. So let's say I don't want to see the red color again. So I just, maybe I'll just leave on the screen here. What happened to the second equation? Okay. Second equation is sine. So I just type sine. Oh, maybe I move a little bit. I go to 4. I type in x equal. Maybe I just assume like the first one, 1 sine, and then I just put in maybe a random number of d. It will give me, okay, this equation is equal to this equation. So you can see that my black color line is shown as your second equation when the time equal to pi over 2 omega. Okay. Now what happens if you want to play around like the second equation that you see on the screen here? You just modify a little bit. X equal b, maybe I put in as e. Try not to duplicate the unknown number here. I keep increasing the level of the alphabet. All right. So D, E, then I use sine F, so that I can play around. What happened? It do not allow me to. Okay. Sine F, sine G, sine 1. Hold on, yeah. I'm not sure why suddenly don't allow me to play like number 1. Okay, but anyway, you get the idea. Maybe I change this one to G. Okay, so maybe the alphabet sometimes, because the E sometimes in the computer it means epsilon. It means 10 power something. So I will change it to H. Then you'll see it'll give you the slider to play. So we play with H. So you see what happened if I change my magnitude for my second scenario, t equal to pi over 2 omega. If I change the H magnitude, we did this one. So it will change the shape of the red color. Let me change the color. Oh, it not allow me to change. All right. But actually, you can change. There are some setting that you can do. Okay, then what is interesting, I want you to explore a little bit on the function. If you click this one, you can change the value on the axis. Last time we are not able to see this table. but this equation allow you to change the number of the table. It will help you to plot lah. Okay, so okay, let me hide the number 4. I hide number 2. Okay, I delete the first one again. Okay, never mind. I'll just put as 1. Okay, maybe I hide this one. Put as 1. Okay, then I put side by side with the photo. So as you can see, when your time equal to 0, which is represented by the blue line, which is this line, then you copy the shape lah, from 0 until the thing. Important that you copy the shape, then you put in your answer sheet. The y is y-axis, and then the horizontal one, you just use the time that you calculate. So this one is minus 2 u over omega, which is, if you assume that this 1 unit here is u over omega, u naught over omega is 1. So you can calculate lah. You can calculate the value of your omega here. So in this case, I'll put as 1. I put as 1, but the shape will be following the sinusoidal shape. Okay, so here you can just plot the graph, and it can show you that it's actually following the mathematics model. Okay, the dashed line here is t for the second scenario, t equal to pi over 2 omega, which is the red color line. Okay, now again, for this module, you're allowed to use online tools or online calculator for you to speed up your answering time. So don't worry. Important is I want you to understand how to illustrate or explain things. That is more important for this module. All right, now any questions so far up to section A here? Any question? Anyone you don't understand? Why suddenly we can get this shape?
No, sir, I understand.
Okay, good. Raj, Yong, Danish, Ku.
Okay, sir. Sir, can you explain again, sir, this one?
Which one?
The
Which part?
line thing. Yeah.
Okay, you understand how we arrive at this?
Yeah.
Okay, so you don't understand how to use the tools, is it?
Yeah.
Okay. So again, apologize for Shirley and others that already know. So you just go and Google graph plotter. So go to the first one. And then you just type in the equation that you see here. So again, u naught and omega is a constant value. Agree? Who just now? Dinesh, is it? Or
yes, sir.
Yeah, Dinesh. So you know that this one is a constant value, correct?
Yeah.
So you can put in any number you want. So x equal to, maybe the simplest one is 1. So I just put 1 on the screen there. Then it's a cos equation, right? Just type in cos, and then this one is the unknown value, because omega times y equal to v naught 0. Y is the unknown value, but we want to find the shape. So of course you can calculate the value, but I would rather put this bracket value as unknown. So how do you represent unknown in the mathematics? You just put an a there. Put an a, and then minus 1. So minus 1, then bracket. You get the shape of the first scenario, t equal to 0 d. Okay, Dinesh, you understand?
Yes, sir.
Then the second one, do you need me to further explain the same concept? Dinesh, you need me to explain the second
sir.
line?
No need, sir. No need, sir. Yeah,
you understand already, yeah?
Yeah.
Okay, so same method for this one. So x equal to, I assume this one as a constant value 1. Of course, you can play around with these tools. So when you okay, then you see the blue color come out. So this is the answer that I'm looking for. You just copy the one that on the top or at the bottom. It depends on the domain that I'm asking for. So normally, just to illustrate, the one that more than positive, Because why we not interested in the below? Because you look at the diagram on the right hand side, you are looking at a sprinkler. Sprinkler head here is here. This line is the sprinkler head bar here, x axis. So this the one that below here is not relevant to the answer. What we're interested is here, the one that above the x axis here. So we are focusing on this area rather than this one. Okay, so this is how we read the data. We go for the second one. Also the same principle, but just a little bit more. The second section is B, path line. Same at origin and the two scenario. Origin, again, later you need the origin and the t to find the constant value, c. So origin 0, 0, t 0, t equal to pi over 2. I think this one I accidentally delete the omega or something. It should be omega. Huh? There's a 2 pi over 2 omega. All right, so again, for B, you write the equation just to remind yourself that you have a velocity field, and remind yourself that this vector form consists of u and v component. All right, and remind yourself also how you calculate the velocity using differentiation. U is velocity in the x direction. So u equal to dx over dt means that what changes in the x direction, how many have you moved divided by time, you get the velocity or the speed that moving along x-axis. Same with the y. Y, of course, vector form, we use v equal to dy over dt. So by having this one, you can continue with the equation that's shown on the screen here. So you know that your u in the velocity field equation is u naught sine something. Your v equal to v naught. This step is to find path line. Yeah? Try not to mix with the previous one. It's a total different things already. We are looking at path line. Just now it's streamline. Now we are looking at path line. So path line start with the equation, velocity equation, velocity field equation, pull out the u and v, and then define how you find velocity for u, how you define velocity for v in the y direction. So mathematic form, u equal to dx over dt, v equal to dy over dt. Once you have this one, combine with the velocity field information, you combine these two, you have your dx over dt, dy over dt. This is the differentiation equation. Once you get differentiation equation, the following step always the same, means that you continue with the integration steps. Once you find the integration equation, continue with the integration steps. So to move further into integration step, you need to move y to y one set, x one set. Means that all the information related to y you pull into one on the left or right, or x you pull to one side also, like just now. In this case, you know that, okay, I'll show you on the screen here. So if you integrate this one, your y, you will get this equation. Okay, maybe a bit too fast for you. I will integrate this one, dy equal integration of dt, sorry, not dt, v naught dt. So this integration equation gives you this one. On the left hand side, you integrate something with a constant value 1. So you will get y. And then on the right hand side, integrate constant value, you'll get v naught t plus c1, because we don't have the boundary condition for your integration. Clear? Clear why suddenly you can get y equal to v naught t plus c1. This one you get from this differentiation, second differentiation equation. Okay. Let me erase whatever you see on the screen. You do for the second one already. Go back to the first equation, dx over dt equal to something. Repeat the integration step like what you can find for your y equation. Repeat the same for the x. You move your dt to the right. Okay. Then you integrate left hand side, integrate right hand side. Okay. Now this one is a bit faster. So dx over dt equal to u naught sine w something. You can write, you can rewrite in u naught sine w c1 over v naught, because you can cancel out. Once you simplify this equation, it looks complex, but every time when you simplify things, it will reduce to a more simpler equation. With this at your screen here, you will see that if you substitute omega into the first one, substitute omega into the second one, you can cancel omega t and omega t. You only have c1 v naught times the omega. So of course with the negative sign there. All right. So the last equation that you see on the screen here actually is a simplification or rearrangement of your equation. All right. Just to make things simple when you solve. So if you can simplify, then you simplify. If not, you can still continue using this one. It's only that it will give you a longer calculation. Yeah. Then you integrate to the along x-axis like what you did for your y component just now. You will get x equal to minus u naught sine something t plus c2. So by comparing these two equations, y and x equation, all right, y and x equation, you will have you will have C1 and C2 equation there. Okay, you have C1 and C2 equation there. So how do you solve for C1 and C2? I go very fast here. You can make it as your homework. So again, just apply the boundary condition to get the constant value. In this case, you have three information: origin, time 0, and this one another case, t equal to pi over 2 omega. Right. So the first case, you substitute y equal to 0, x is 0, t equals 0. You manage to get what's your c. So for the first case, your c1, c2, you can calculate as 0. All right. Then the path line equation for section B will be, if you substitute all the boundary condition and the constant value that you find, your x will be 0. Your y will be v naught t. So this is your answer for the first case where your t equals 0. Okay, you continue the same principle. You do it for the second case. All right, now this slide is the second case already, where I changed the pi 2, although the information looks same. But I changed the pi 2, it should be 2 omega. Okay, I think the t should be 2 omega. Let me check. The t, I'm not sure whether I accidentally delete the omega or the t should be pi 2 omega. But anyway, important is the principle of solving question. You just substitute the t inside there. You'll get your constant value C1 and C2. Okay, so once you get C1 and C2, you substitute into the equation. So you have two sets of equation. Once you substitute your constant value C1 and C2. So this is the second set answer. X equal to this one, Y equal to this one. So for second set, the steps is quite straightforward. What is important for second section to find path line is to recall the definition of speed towards x-axis and y-axis. Then you substitute, get the differentiation equation, integrate, get the constant value c, write the answer. Then you get the solution already. Okay, so for B, you have 4 equation. All right. So let me do a bit quick. So path line, you have 2 equation. So you can plot also using the method that I just showed you. You just key in x equal to something minus something. So t, you can put more than 0 if you want, or it's a positive value. You can put as 1. Usually I like to put as 1. It will give me a cleaner result. So put as 1 minus something, minus A, B, or C here. You'll get the shape. Okay. Then you will get y. Actually, when you combine, you substitute. Okay, you have 2 equations, right? How you arrive at this one? It's actually you simplify these 2 equations. You simplify y and x. How you simplify? You having the same term here, which is a t. You rewrite this equation, the x equation, in terms of t equal to something. T equal to something x plus this omega something. You substitute your t inside here. After you substitute inside here, you rearrange the equation, you'll get this one. This one is much simpler equation. Okay, so y equal to something, it will give you this line. Okay, so just show you. So you have 2 scenarios. One is when t equal to 0, you have x equal to 0, y equal to v naught t. So when you plot your graph, when the x is 0, right? When x is 0, it means that it moves along y-axis. Because along y-axis, all the point of your x is 0. And your y equal to v naught t. V naught t, v naught is the constant value. T also 0 in this case. So y is 0, so it's a straight line. Okay. And for t equal to pi over 2, y equal to constant value, x means that is you can assume that this value is positive value. So y equal to mx plus c, your c is 0. Okay, recall the general equation of your linear line, mx plus c. You don't have c here, means it's crossed origin. C is 0 is crossed at origin. Your gradient of your line is v naught over u is a constant value. So when you assume that your m is positive, you have a slanted line like this. So this is how you plot your line. Okay, so this is B. This is B. They give you the time at t equal to pi over 2. I think I missed I deleted the omega. Okay, the omega this one should have 2 omega. Okay, I deleted the omega already. Okay, yeah. So in your tutorial question, help me to edit the question a bit. Right, it should be 2 omega. All right, so it means that if you change the omega, you're able to change the either is if the x is negative, then the m is negative, means that your line will be like that. Okay. All right, now the C1, I see one. Let's go a little bit more. 2 more slides, then we call it a day. Okay. Then after that, the section C is a strict line. Stick line is the shadow. You still remember the basketball that passed through? Okay, let me bring you back to the slides. Okay, now strict line is the photo that you take for the basketball, the gray line. So how do you define it in mathematics way? So I show in these slides. So of course you can read through. There are lots of information that you need to progress because section C, just now I mentioned, is a mathematics interpretation. So stick line, let me give you the photo first. Now, you know that you already calculated the path line just now. Okay? You already calculated the path line, which is a straight line from the origin. So straight line is actually the shadow, or is the history of the particle itself. So the first statement is just say that the straight line from origin t equal to 0 is actually a locus of the particles. All right. Then each particles, it will travel in the straight line. So you see on your screen here, you have the small dot here. The first dot is t equal to 1. Second is t equal to 2. Third one is t equal to 3, and so on. So this one is like the basketball that I showed you just now. It's recorded through the camera, the slow motion camera. You have to capture the first t equal to 1, t equal to 2, t equal to 3, t equal to 4, t equal to 5, t equal to 6, and so on. Okay. Now, why the path line like a fan shape? Now I need to recall. Just now, you know that your head is oscillating, and it's like you are spraying water, and you are shaking the hose head from left to right. So your path line actually, it will be in the fan shape, like what you see on the screen here. You are moving your head to the left and to the right in the sinusoidal equation just now. So your slope of the line of your path line just now will be positive and negative of your V0 or U0, the M value just now. Okay, that's why you're seeing all these straight line in the dash form. Okay, so this one, the second line represent telling you why there's a fan shape of the path line, because your slope is keep changing, positive, negative, when you shake the head of the sprinkler. Okay. Then the third statement, it tells you that a particle passed through the origin. It will record it at a different time, like what you see at the basketball photo just now. So I'm showing here is the dot, solid dot here that tell you the history of the particles, how far it traveled. Okay, so if you pay attention to the individual water particles, so it will go like this, right? It will go like this. If you capture, you will see that the water particles will swing like this. Okay, will swing like this. Then the net results is that you're seeing a movie. A movie actually is a repetition of a stationary photo. So if you're in the photography, then you know that you can convert a file of photo, you can convert into video. So video file actually is a repetition of the individual photo. So if you combine all the motion photo, you will see the straight line that you see on the photo here, or on the picture here. So you will see that it actually it will be like a dye shape when you spray dye into the air. So you have this sinusoidal form. And of course, when you consider the realistic of the atmosphere, you have unsteadiness. Then the shape will be different. The shape can be this one, or it can be this one. It can be a small magnitude or big magnitude, depends on the value of the vibration of the head, the left or right motion that you put in. Okay. However, the shape will always same. It will show you the sinusoidal characteristic. Okay. Now with this, I end the recording.